everyone, welcome to this video. In this video, we are going to discuss the matrix. This is lecture 1 or part 1 of the matrix. In the next video, we will continue the others part. In this video, we want to discuss about the basic of matrix with some term associated with the matrix. We want to discuss about this. This is important for B.Sc physics honors, for IIT JAM, CSR NET, set, get examination also. Okay, if you want to see the syllabus of this portion from the University of Calcutta for the first semester of the physics honors, the syllabus says that within the matrix syllabus, addition and multiplication of matrix, null matrix, diagonal, scalar, unit matrix, transpose of a matrix, symmetry, skew symmetry matrix, conjugate of a matrix, Hermitian skew Hermitian matrix, singular non singular matrix, orthogonal unitary matrix, trace of a matrix. In this video, we want to cover the this part A. In the next two video, we will cover up the next portion. Okay, you can see also for IIT JAM examination, the syllabus written as only matrix, jest also, get, TIFR, WB set, West Bengal set, the written as only matrices. Actually, matrices mean within the matrix the total syllabus is like that. In the CSR net, this is elaborated at the matrices, Cayley-Hamilton theorem, eigenvalue, eigenvector, etc. Okay, I think clear about the syllabus of the matrices. For University of Calcutta, I follow this syllabus. Okay, in this video, I want to cover up the first part of this syllabus, which is part A. So let's start. What is matrix, or what is the need of a matrix? What is the need of matrix? At first, we want to understand what is the need of the matrix, right? Suppose you have a three linear equations such that 5x plus 4y minus 3z is 9, 3x minus 5y plus z is 20, and 8x plus 2y minus 9z equal to 52. If you want to solve the three equation to find the value of x, y and z, what will be the procedure? You can eliminate z from these two equation, and from these two equation you will get the equation xy, and you can eliminate y from two equation, you will get value of x, then put the value of x in any one equation, you will get y, and then put the xy, you will get the value of z. This is the process by which you can solve these three equation. Is a long process, but if we want to find out the these three equation in a matrix form such that we can write this as a 5 3 8 4 minus 5 2 3 sorry minus 3 1 minus 9, that into x, y, z equal to 9, 20, 52. Okay, this is a formation of matrix. This is a matrix 3 by 3. What is 3? This is the number of row. This is number of row. Row 1, row 2, row 3. That's why number of row. This is the number of row. Okay, and this is the column C1, C2, C3. That is the number of column. Okay, so this is the order. Actually, this 3 by 3 is the order of matrix. This is the notation of a matrix 3 by 3, where these three are actually order, 3 row and 3 column. This can be written as, if we take this is a m, and this can be written as x, and this is a, suppose taken as a. So x, what will be the x? X will be nothing but m inverse a. So if you can find out the inverse of a matrix, we will learn how to get inverse of a matrix. If we get the inverse of matrix, just product, if you know the property of product of matrix, you can easily solve the 3 by 3 equation. If there is a 50 variables from x1 to 50, you can also solve by this matrix process, right? If there is 3 equation, you can solve x, y, z by eliminating process. This is possible, but if you have a equation 50 equation and 50 variables, 50 equation and 50 variable, how you can solve? How you can solve? Then the matrix process or the matrix presentation is very useful for such kind of equation. Okay, this is the introduction of the matrix, why the matrix was need to represent a large equation or the large equation in a small notation. Okay, to represent large equations in small notation. Okay, in small notation, large equation can be represented in the small equation is the use of a matrix, right? So the in a matrix, you know, there is a some number of row and some number of column, and the order of the matrix written as the number of row into number of column. Next, addition and multiplication of matrix. Suppose first one is the addition. Suppose addition. I want to cover up the syllabus of University of Calcutta. That's why I follow the syllabus of University of Calcutta Physics Honours first semester. Okay. Addition of matrices. Matrix is singular form, matrices is a plural form. Okay. Take two matrix. A is any matrix. The element written as A11, A12. This is the position of row 1, column 1. This is the position row 1, column 2, A12, A13 dot 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 A1n. This is the position number row 1 and column n. Similarly, this is 2 1, that is the row 2, column 1, 2 row 2, column 2, 3 row 2, column 3. This is the A2n, and so on. You can say this is the M1 taken as the number of row is M, and this is column 1. So this is M2, this is M3, and so on. You can write this is Mn. Okay. So the number of row is M and number of column is N. So the order will be M. For addition of two matrix, the order and the number of order and number of column must be same. For addition, condition, the condition is number of row of two matrices must be same. Number 1, number of row of two matrices must be same. And another two property is number of column of two matrices must be same. Clear? The number of row of two matrix will be same and number of column of two matrix will be same. Taken another matrix, suppose this is a B, and the row and the number of row and the number of column of B will be equal to the number of row of A and number of column of A. Okay, so this can be written as B11, B12, B13 and B1n. This is B21, B22, B23, 23, B2n. In such a way you can say this is BM1, BM2, BM3 and this is BMN, and number of row is M, number of column is N, so the order will be Mn. Since the order are the same, we can add these two matrix A plus B. Okay, what will be the A plus B? The position, the element at the same position will be added. So this will be A11, B11. Next to A12, B12. Same position elements are added. A13, B13 and so on. A1n plus B1n. Next, A12, A21, B21, A22, B22, A23, B23, and A2n, B2n. And this same way, this is AM1, BM1, AM2, BM2, AM3, BM3, and AMN, BMN. Just add the elements at the same order, and the order of the matrix of the additive matrix will be the same as the for in case of individual matrices. This is clear. If there is a difference subtraction, this will be minus. Simple, very simple. If this is difference, I want to rewrite this in the different color, in the white color. Minus, 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 minus. For plus, plus, and for minus, minus. Next is the multiplication of matrix. Multiplication of matrices. Okay. For multiplication of matrix to matrix, you need to suppose A is a matrix A11, A12, A1n, A21, A22, A2n, AM1, AM2, AMN. This is the row is M and column is N, so order will be Mn. And the another matrix B, this is B11, B12, BNP. Suppose this is a B1, sorry, this is a 1P, taken as a 1P, 21, 22, 2P, BN1, N2, NP. So this will be N cross P. The condition for multiplication of two matrices is the number of column of the first matrix will be the same as the number of row of the second matrix. What is the condition? Condition to perform the matrix is number of column. This is the column of first matrix will be same as number of row of second matrix. Okay. So for number of column, the next one is the same as the number of row, that is the first one of the second matrix. If these are the same, then the multiplication is possible, and the multiplied matrix and the order of resultant matrix will be this row and this column. Row of first matrix and column of second matrix. Clear? So if C is the product of AB, then the order will be M cross P. Clear? The product will be if possible if the number of column of first matrix is equal to the number of row of second matrix, and the order of the resultant matrix or the product matrix will be the same as the number of row of first and number of column of second. Clear? And how the product will be possible? AB taken this as the in the sorry in such a direction, suppose you remember like that, in this direction, and this is in the, this is the horizontal and the vertical line. That's mean you need to product a11 to a b11, that is a11 b11 plus a12 b11 21 b21 plus dot a1n bn1. Clear? This is the first element of this matrix. If you write in here, this is m p, this is the first element, this is the first element, that is the, you can see this is c11. Clear? This is the c11. So you can say in the complex form, this is c ij, this is nothing but a I m or k, suppose you can say k b k j, and this is I is 1 to m, this is the number of row m, and j is nothing but 1 to p. Clear? And k is, sorry, the here the summation will be upon the k is nothing but 1 to n, the variable. Okay, so this is the cij in the summation notation. Clear? So this product will be a11 b11 in the horizontal, this is that element with that element, that element with that, and that, and so on. This is the, we will get the first one. And the next, in the similarly for second, next, for this column, product with that you written here, for that written here, and so on. This product will be very simple. If you don't have problem, you must comment in the comment box. Go to the next one, you already know this. Next is null matrix. What is the null matrix? What is the null matrix? The matrix whose all elements are 0. That means if a matrix A, if its all elements are 0, all elements are 0, m cross n of all element is 0, then this is called the null matrix. All elements are 0. Okay. Suppose you have O3, that's mean, or 3 into 4, that's mean there is a matrix 3 by 4, number of row is 3, number of column is 4, and all elements are 0. Okay. If we multiply with a 0 matrix, we will get 0. If we add it with 0 matrix, we will get this matrix. This is a property, simple property. Null matrix is the, all elements of the matrix will be 0. What is the diagonal matrix? Diagonal matrix, diagonal matrix. What is the diagonal matrix? The matrix whose elements are only present in along the diagonal. That means, suppose this is a matrix and the element are present along the diagonal and the other element will be 0. Okay, this is a 3 by 3 matrix and the elements will be along the diagonal. For that, you remember this must be a square matrix. Square matrix means the number of row and number of column must be same. Square matrix, that is the number of row is equal to number of column. Square matrix is the number of row equals to number of column, all of whose elements except the diagonal are 0. Except the diagonal, all elements, this is the off diagonal elements, only diagonal elements are present and the off diagonal elements will be 0. This is called a diagonal matrix. Diagonal elements present, diagonal elements present and off diagonal elements are 0. So for off diagonal elements will be 0, only diagonal elements are present in a square matrix. You must remember the term square matrix. For square matrix, that is the number of row and number of column is the same. For that, only if the diagonal elements are present, this is called the diagonal matrix. Next one is called the scalar matrix. What do you mean by scalar matrix? Scalar matrix. What do you mean by scalar matrix? What do you mean by scalar matrix? If in a diagonal matrix all diagonal elements are equal, if the diagonal elements are equal, if these diagonal elements are equal, if these are different, this is called diagonal elements. If the diagonal elements are equal, this is called the scalar matrix. If in a square, no, you can say the diagonal matrix, diagonal matrix, all the diagonal elements are equal, it is called scalar matrix. Scalar matrix. Clear? If the elements of the diagonal means of diagonal are 0, only diagonal are present. Of a square matrix, you know diagonal matrix means a square matrix. Clear? For square matrix or in a diagonal matrix, the element will be the same. If if the elements will be the same, then this is called the scalar matrix. Okay, for this is scalar matrix. Next one is the unit matrix. Unit matrix. What is the unit matrix? In the scalar matrix, if these elements are the 1, if these elements are 1, for diagonal matrix only these elements are present, they can be different. So special case of diagonal matrix is the scalar matrix where the elements are equal. Special case of the scalar matrix is unit matrix whose value of these elements will be the 1. Okay, so this can be written as, suppose I3 means this is 3 by 3 matrix, and this 3 you can write because this is a square matrix, number of row and number of column are the same, that's why this is called the scalar matrix. And I3 means this diagonal elements are the 1. So a scalar matrix of order n is said to be unit matrix if each of the diagonal elements are equal to unity, and this is also known as identity matrix. This is also known as identity or unit matrix. Okay, So unit matrix is the special case or subset of the scalar matrix whose the element of the diagonal are the unit 1. This is called the unit matrix. Next is trace of a matrix. What is trace of a matrix? Trace of a matrix. Trace of a matrix. This is very simple. Suppose you have a any matrix 1, 2, 3, 4, 5, 6, 7, 8, 9. The sum of all diagonal elements. Sum of the diagonal elements called the trace of this matrix. This is the diagonal elements. Sum of these diagonal elements called are the trace of this matrix. Sum of diagonal elements. Sum of the diagonal elements of a matrix is called trace of the matrix. Clear? So trace is nothing but the sum of the diagonal elements is the. So here the trace of this matrix, this can be written as TR. Trace will be 1 plus 5 plus 9, that is 15 is the trace of this matrix. Okay. Here is the property of a trace of a matrix. The property says property. What is the property? Property says the trace of the product of two matrix A and B is independent of the order of multiplication. That's mean the trace of AB. That's mean if product the A matrix with B matrix and then find the trace is equal to the trace of BA. Clear? So if we multiply A matrix with B matrix and then find the trace, and if we multiply B with A and then find the trace will be the same. So there is a the trace will be independent on the order of multiplication. Next one is the transpose of a matrix. Next one is the transpose of a matrix. Transpose of a matrix. Okay. Transpose of a matrix. Transpose is if this A vector is written as 1, 2, 3, 4, 5, 6, 7, 8, 9, then A transpose written as AT, or sometimes this is written as A prime, or sometimes this is written as A nearly symbol. Okay, these are the notation. The transport mean the change in the row column. That's mean this is the written along the row, we write this along the column. This is the transpose, interchange of row column. So you can see along the row and write along the column 4, 5, 6, and this is the 7, 8, 9. Clear? This is the transport of this matrix. So this is to the transport of a matrix is the row and column with the interchange interchange or interchange row column, interchange the elements with respect to row and column, with respect respect to row and column. Clear? So the transport of a matrix is nothing but interchange of the row column is called the transpose of a matrix. Now the point is the symmetry and skew symmetry. Symmetry, if the matrix is equal with the transport. So first one is the symmetry. Symmetry, symmetric matrix. Symmetric matrix. What do you mean by symmetric matrix? If any square matrix A is equal to its transport, that means consider A is any matrix that is 1, 2, 3 symmetry. Suppose 3, 5, 9, 3, 9, 7. Okay, this is a matrix. If you want to find out A transport, what will be the value of A transport? You just see along the row and write out along the column. 1, 2, 3, 1, 2, 3, 2, 5, 9, 2, 5, 9, 3, 3, 9, 7, 3, 9, 7. You can see these two matrices are the same. There is no difference. So A is A transport. Clear? If A is A transport, then this is called the symmetry matrix. Then if A equals to A transport, then A is symmetric matrix. So if A is equal to the A transport, that means the matrix is equal to its transport, then this matrix, you must remember this all about the square matrix. This all about the square matrix. If a square matrix A is equal to its transpose, then A is said to be symmetric matrix. Symmetric matrix. Okay, and the skew symmetry is nothing but if A is nothing but minus of A transport. So this is nothing but that is Aij, the element of the ith row and jth column is must be equal to ji. If this is this whole, then this is called the symmetric matrix. And what will be the skew symmetry? This is symmetry matrix, and the skew symmetry or anti-symmetry, skew or anti anti-symmetric matrix, anti-symmetric matrix. That's mean if A is equals to minus A transport, if you transport A and you can see there is a minus originated, that is in terms of Aij is equals to minus Aji. If this is possible or this is happening, then you can say this is a anti-symmetry. Suppose A can be written as 1, 2, 3, minus 2, 5, 9, minus 3, minus 9, 7. And if you transport these elements, then you 1, minus 2, minus 3, 2, 5, minus 9, 3, 9, 7. This is nothing but the minus of A. So this, since A is equals to minus of A transport, then this is called the skew symmetry or anti-symmetry. So for symmetry or skew, to check the symmetry or anti-symmetry or does not obey the any relation, so you must to find out the transport of this matrix. How you can find the transport of this matrix? Just interchange row column. You see along the row and write down along the column, or vice versa. You can see also along the column and you can see along the row. Clear? Okay, next one is the conjugate of a matrix. Conjugate conjugate of a matrix. Conjugate of a matrix. Conjugate of a matrix. What is the conjugate of a matrix? If A is a matrix with a complex number, before that we all matrix written is the real number. Okay, before all the example we write down the elements in the real number, but if the element of any matrix will be the complex number, then the complex conjugate of each number is called the conjugate of a matrix. If A be a square matrix, then its complex conjugate A star, this is written as A star or A complement, supplement, sometimes this is called a conjugate AC, is such that the elements of A star are the complex conjugate of elements of A, are the complex conjugate of the elements of A. Clear? For example, if A is written as 1 plus I, 2 minus 3I, 2 5I. Okay. So what will be the value of A complex or A star or A conjugate? This is nothing but the complex conjugate of all elements. So complex conjugate 1 plus I is nothing but 1 minus I, and 1 minus 3I is 2 plus 3I. The complex conjugate of real number is 2, and this is the minus 5I. So this is the complex conjugate of or conjugate of A. Conjugate, this is the conjugate of A. Clear? For note, for real number, you know, for real number there is no change. So for real number, for real matrix, you can say A star is equals to A. Clear? For real matrix the complex conjugate is the same as for elements A, that's why A star will be A for the real matrix. That means all element within the matrix will be the real, then this conjugate also be the same, but in case of complex element within the matrix, then there is a existence of the conjugate of this matrix. Clear? Similarly, as this is the trace transport dagger. Similarly, transport of a matrix, you know, transport of a matrix is nothing but the change in the row column. Row column interchange is the transpose and the matrix, and by transpose of the matrix you have its property symmetry and unsymmetry. In the same manner, if we interchange the row column for in case of the complex, matrix, complex element of the matrix, this is called the dagger. A dagger. This is nothing but the A dagger. Dagger of A. Dagger of A. This is nothing but transpose of a complex conjugate matrix. That's mean if you have a matrix A, you need to complex conjugate and then transport. Okay, this is called the A dagger. Suppose you have a that is 1 plus I, 3I, 2, 5I minus or you can say 4 minus 5I. Clear? So what will be the value of conjugate of A? A star is nothing but conjugate of A. So you just put the complex conjugate component of each element. So this will be 1 minus I, this will be minus 3i, this is 2, this is 4 plus 5i. This is the complex conjugate of A. What is the A dagger? A dagger is the nothing but transport of this complex conjugate of this matrix. So you just transport of this matrix. What will we get? 1 minus I 2. You see along the column and write along the row. Minus 3i, this is 4 plus 5i. Clear? So this is the complex conjugate transport or the A dagger. So in case of the real matrix or the matrix with the real elements, you see symmetry, skew symmetry. In the same manner, in case of the complex elements of the matrix, you can see the Hermitian and the skew Hermitian. So this is the Hermitian matrix. Hermitian matrix. Hermitian matrix. What is the Hermitian matrix? See, if A dagger will be equals to A, you know what is A dagger? A dagger is nothing but transport of a complex conjugate of any matrix, right? So if A be a square matrix, then its Hermitian conjugate, this is also known as Hermitian conjugate, Hermitian Hermitian conjugate A dagger is obtained as a transpose of the complex conjugate of A. Just we say just written in the written form. Okay. Thus, if A dagger will be equals to A, then A dagger is the Hermitian of matrix A, is the Hermitian of A. Clear? If A dagger will be equals to A, then the A matrix can be written as or the call be as the Hermitian matrix. How we can find A dagger? Nothing, just complex conjugate of element and transport. Clear? If this will be equals to minus A, for example A equals to 1 plus I, 2 minus 3i, 2 minus 3i. Just sorry, just okay. And what is the skew Hermitian or anti-Hermitian? Skew Hermitian, just like a symmetry and skew symmetry. Clear? Hermitian, just like a symmetry and skew symmetry. Okay, matrix. If A dagger will be the minus A, you just find out A dagger, and if you got A dagger will be minus A, then A is skew Hermitian matrix, skew Hermitian matrix. Clear? So we need to find out Hermitian or non-Hermitian or the skew Hermitian. You must take out the complex conjugate and then transport. If we will get this relation, this is called Hermitian matrix. If we got this relation, this is called skew Hermitian matrix. And if we do not get any others relation except these two, then you must say this is a non-Hermitian matrix. Clear? The next one is the singular and non-singular. What is the singular? singular and non-singular matrix. What is the singular and what will be the non-singular matrix? If the determinant of the matrix, you know, to find you all know the determinant. What is the determinant? If the determinant of the matrix will be the 0, then this is called singular, or if not equals to 0, then this is called non-singular. Very simple. If the determinant of any matrix be 0, then the matrix known as singular matrix. That is dit A equals to 0. And if the determinant of any matrix not equals to 0, of any matrix is not equal to 0, then the matrix known as non-singular matrix. Simple, very simple. That is determinant A, not equals to 0, then this is called the non-singular matrix. I think clear. Next is orthogonal. What is the orthogonal matrix? What is the orthogonal matrix? Orthogonal matrix and the unitary matrix. Orthogonal matrix. What is the orthogonal matrix? Suppose A is a matrix, any matrix. Suppose this is a 0, 1, 1, 0, and you find A transport. What will be the transport of this matrix? 0, 1, 1, 0. Just interchange the row column, you will be get the same thing, and multiply them. A transport. What will be the value? 0, 1, 1, 0, and the 0, 1, 1, 0, 0, 0, 1, 1. So this will be 1. 0, 1, 1, 0, that is 0. 1, 0, 0, 1, that is 0. 1, 1, 0, 0, that is 1. So this is nothing but the unitary matrix with order 2. If the matrix multiply with its transport gives a unitary matrix, sorry, unit matrix. This is not unitary matrix. I is the unit matrix. Clear? I was the unit matrix. I was the unit matrix. I was the unit matrix. If the product of the matrix with its transport gives you unit matrix, then this is called the orthogonal matrix. The A is B. So A is orthogonal matrix. Clear? Matrix. So if the product or multiplication, if you can say multiplication, if multiplication of any matrix with its with its with its transpose matrix gives you transpose matrix result unit matrix. Then the matrix is known as orthogonal matrix, orthogonal matrix. Clear? I think clear. In the same manner, in case of the complex number related matrix is called as the unitary matrix. What will be the unitary matrix? Unitary matrix. What will be the unitary matrix? What will be the unitary matrix? Same, if a dagger, or you can say the reverse one will be the identity. In the same, there will be must be A transpose A also equal with the I in case of orthogonal matrix. So in case of orthogonal matrix, you can say A transpose equals to A transpose A equal to I in case of orthogonal matrix. In case of unitary matrix, you can written as A dagger. Dagger, you know, transpose of the complex conjugate matrix equals to A dagger A. This must be equals to I. This is the property of unitary matrix. For example, you can say A is 0, I minus I 0. This is the example. So what will be the value of A star? A star is the complex conjugate. This is 0 minus I 0, and the A dagger just transpose. You will be got the same things. No, I, this is minus I 0, and product them A dagger will be get the 0 I minus I 0. This is the 0 I minus I 0. What will be the value? 0 0 I minus I square, that is 1. This is 0 0, that is 0 0, minus I minus I into plus I, that is minus I square. Minus I square means 1. So this will be I2. Since a dagger gives you I, so here A is the unitary matrix. So if a square matrix A and its Hermitian, you know, Hermitian is the nothing but the transport of the complex conjugate. Hermitian conjugate A dagger B such that A transport equals to A transport A will be I, that is the unit matrix. Then A is said to be unitary matrix. Clear? I think clear. Next one is the inner product. What will be the inner product? What is the inner product? What is the inner product? This is useful. If A is a matrix, this is the row matrix, that is only elements along the row. This is the row matrix. Clear? Only elements along the row. And another is the B row matrix, B1, B2, B3. This is another row matrix. If you product A and B, inner product of A and B can be represented as like that. This is the representation. and this is nothing but A product of B transport. What is the A1, A2, A3, and transport of B will be the B1, B2, B3. If you product this is the number of row is 1 and column is 3. This is the number of row is 3, column is 1. So if you product these 3, 1 cross 3, 3 cross 1, these 3 are equal. So product will be possible, and the order of the resultant will be 1 cross 1. Clear? So the elements will be A1 B1 plus A2 B2 plus A3 B3. This is the inner product of the A and B. For inner product, you must the transport of the second element, or in case of the complex conjugate, you must dagger. This is the transport of the complex conjugate element. Okay. This is all are covered for the syllabus of the complex conjugate of the University of Calcutta in the part A. I need to this part A, you can see addition, multiplication, null matrix, all are 0, diagonal matrix, that means only diagonal elements are present, of diagonal is 0, scalar matrix, diagonal elements are the equal, unit matrix, the equal elements will be the unit. If all the diagonal elements are unit and off diagonal is 0, this is unit matrix. And transport of a matrix, just interchange the row column. Symmetry is Q symmetry. If we interchange row column and the same, we will get then symmetry. If we get with a minus, then Q symmetry. Conjugate means the complex conjugate, I replaced by minus I. Hermitian and Q Hermitian, if the matrix is the same with the complex conjugate or the dagger, then Hermitian with negative, this is Q Hermitian. Singular, the determinant will be 0, non-singular, determinant not equal to 0. Orthogonal, A transport will be I, unitary, A dagger will be I. Trace of a matrix, the sum of the diagonal elements. I think covered this part. I want to give you some homework. Just write this homework and do that, and comment in the answer write down in the comment box. Homework 1. I want to change the color. Homework 1. Determine the matrices A and B where A plus 2B is equals to 1 2 0 3 6 minus 3 3 minus 5 3 1 and 2A minus B is nothing but 2 1 5 2 minus 1 6 0 1 2. This is the homework 1. Homework 2. Solve for x y z t where y plus z, x plus z, 7 minus t, 6 minus z is equals to 9 minus t, 8 minus t, x plus y, x plus y. Okay, just compare the elements. You can solve this. You must solve this question and comment in the comment box. Okay, and that's it. And another one, I want to give you homework 3. If A is given as 0 1 2 1 2 3 3 1 1 and I is nothing but the unitary matrix, so 0 0 0 1 0 0 0 1, find matrix B such that A into B will be I. I request all of you to solve these three questions and comment in the comment box. I will give you the others practice question in the next video. Thank you. This is all about me, and this is my contact details. You must contact with my WhatsApp or the Telegram channel regarding any physics related question, and you must contact if there is any problem in this video. Okay, this is my YouTube channel details. Go to this channel, you get the all the videos which already uploaded in this uh, channel. Subscribe this channel if you new in this channel. Press the bell icon to get the notification when I will be uploaded the new video. Share this video to your friends so that she or he also get benefits from this video. Take care. We will meet in the next video as soon as possible. Thank you.